Okay, so here's part 2 of our 4.4 notes. We're going to once again factor quadratics when a does not equal 1. So we're just going to continue what we've been doing, okay? So let's do this first one together. So we have 6, so we need to make sure we figure out all the numbers that multiply to 6, or the factors of 6. We got 1 and 6 and 2 and 3. 5 is going to be the same. Here we only have 1 and 5, okay? Now we create our 2 sets. Now, notice how this is a little bit different than the last one. The 6 actually has now multiple pairs of factors. So when that occurs, and when we have to work on figuring out which pair works, we're going to start from the bottom of our list and work our way up. The reason we do that, it's most likely that our answers are going to be at the bottom of our list. Now, for the 5, there's only one pair, so we have to use that. So we have to use 1x and 5x. Okay, but now this is where we decide, do we use 2 and 3 or 1 and 6, okay? Let's try 2 and 3 here. So I'm going to have 2 and 3. So always start from the bottom. If you have multiple pairs, start from the bottom of that list and work your way up. Okay, so we're going to multiply it in the middle. So we have 2 times 5x gives us 10x, and 1x times 3 gives us 3x. Okay, does 10 and 3, if we add or subtract, give us 17? No. So let's switch. So now I have 3 in the front, 2 in the back. Okay, do 5 and 3, which gives me 15x. 1x and 2, which gives me 2x. Okay, if we added or subtracted these, would this give me a 17x? Yes, it would. Okay, so we know if we have both of these negatives, so negative 15 and negative 2, that will give me a negative 17 in the middle. So I have both negatives. I'm just rewriting this so it looks nice. I have now x minus 3 and 5x minus 2. And that'll be my final answer. Okay, go ahead and pause the video and try the next one. Okay, let's see what you got. Okay, 2, we have 1 times 2. 4, we have 1 times 4 and 2 times 2. Okay, for this one, once again, for the 4, start from the bottom of our list here. Okay, start from the bottom. So I'm going to try 2x and 2x. So now I have 1 and 2. So I have 1 and 2. Okay, I do 1 times 2x. And 2x times 2 gives us 4. Okay, 2 and 4, if we added and subtracted, would that give us negative 9? And, okay. Now, the nice part with this one, notice that our x's are exactly the same. So even if we switched the 2 and the 1, we would get exactly the same thing. So that means 2x and 2x don't work. So let's try 1 and 4 here. Okay, multiply the inners, we get 4x, multiply the outers. Okay, 4x and 2x, will that get us to 9? No, so let's switch that 1 and 4x. Okay, 1x times 1 gives us just a 1x. 4 times 2 gives us 8x. So if we think about 1x and 8x, if we added or subtracted, would that get us to negative 9? Yes. Now, in order to get to a negative, both the 1 and the 8 have to be negative. That means both of these will be negative as well. So our final answer here is 4x minus 1, and we have x minus 2. And this also works because if we multiply our constants, so the negative 1 times negative 2, that does add up, or that does multiply to a positive 2. So that works. Okay, go ahead and try the next one. Pause the video and do so. Okay, let's see what you got here. So 3, we only have 1 and 3, and for 2, we only have 1 and 2. So I create my 2 sets of parentheses. I have 1x and 2x. Now remember, make sure you exhaust all the options before saying it's not factorable. So then I have 1 and 3. Multiply the inner, I get 2x. Multiply the outer, I get 3x. Okay? So here, if I added or subtracted, could I get an x? Yeah, I can. So what happens here is that my 2x has to be negative, right? So because of that, we're going to have a negative here, and then the other one's going to be positive. Now, before you say, oh, this is our final answer, this is why I talked about multiplying your constants on the last problem. Notice we need to make sure when we FOIL this whole thing out that it multiplies to a positive 3, okay? So I'm going to go ahead and FOIL this to see if this actually works. And gives us our answers back. So we get 2x times 2, so that gives us 2x squared. Then we do our outer, so we have 3 and x, so that's positive 3x. If we do the inner, we get negative 2x. And then the outer, negative 1 times 3 gives us negative 3. So here we get 2x squared plus x minus 3. But is that the same as our original problem? No, because this is a positive here, right? So we have a positive 3, but when we FOIL it out to see if it works, we get a negative. So actually, therefore, this doesn't work. Though it seemed at first it did. Okay, now we can't say, oh, that's it. We have to go the other way and see if it works, okay? Okay, my first was a 1x and 2. Now I put 1 and 3 in my first set there, okay? So what I'm going to do is switch. So I'm going to have 3 and 1 and see if this works. So I get 6x, and then 1 times 1 gives me 1x. Well, if I added or subtracted 6x or 1x, could I just get an x? No. So this doesn't work either. So that means this is going to be our non-factorable. Or you could also say cannot factor. Okay? So definitely be careful because you are going to have those tricky ones where it seems like, oh, this is the right answer, but it has to multiply and be that same constant on the end. So just be careful with that, okay? Okay, let's try these. So for these here, notice they're a little bit different. Once again, they are binomials. We don't have that middle term. Now remember when we talked about when there's a binomial, there's subtracting, and that term is going to be a square, a perfect square? What did we call those? Difference of squares. So if you notice here, especially on the first one, 9x squared minus 64, what do you notice about 9 and 64? They are perfect squares. So these are going to be our difference of squares. Okay? So when we are doing these, the first thing you need to ask yourself, okay, do these have anything in, or do the terms have anything in common that we can take out? Do they have a common factor? Which we should have been asking ourselves on the last problems, but none of them had them. So let's think about 9x squared minus 64. Do those two terms have anything in common? No. There's no number that goes into both 9 and 64, and they both don't have x's in common. So they don't have a common factor. So we're going to go ahead and just factor it like we would. Now notice 9 is the perfect square. What is the square root of it? It's going to be 3x. So we put 3x in both of them. What about 64? What's the square root of that? It is going to be 8. Now remember, with the difference of squares, we are going to have one that's a positive and one is a negative. And that's just going to be your final answer. So these are nice and easy where you don't even have to do that guess and check method once you recognize they are a difference of squares. Now let's look at 5x squared minus 125. Okay, do these two terms have something in common? Let's think about the number. Yeah, both of them have a 5 in common. So I'm going to go ahead and take a 5 out. Now, do they have a variable in common? No, because only one term has an x. So I'm going to rewrite this. So don't forget, if they do have something in common, you have to rewrite, then you can factor. So I do 5 divided by 5, that gives me just 1, and I'm left with an x squared. 125 divided by 5, that's going to give me a 25 there. Okay. Now I can factor like I usually do. Now make sure this common factor, we keep bringing it down. Don't let it out of your sight. It doesn't disappear like magic, okay? So now I'm going to create my two sets of parentheses. Notice, once again, this is a difference of squares because we have a binomial, two terms. We are subtracting, which also means difference. And basically our constant and the a value are both perfect squares. And we don't have that middle term. So this is kind of going back to what we did in 4.3. We have x and x because our a value here is 1. And what's the square root of 25? That's going to be 5. And don't forget, one's going to be positive, one's going to be negative. Doesn't matter where you put the positive and negative, no. And this will be your final answer here. Okay, let's try the last one together. So you have 36x squared minus 9. Now the first thing we need to decide, do those two numbers have something in common? Yes, they both actually have a 9 in common. That's a little bit tricky one. Now do they both have a variable? No, the last term does not have a variable. So now let's rewrite this. 36 divided by 9 gives me 4. And what's 9 divided by 9? That gives me 1. So don't forget, rewrite, then factor. Okay, I still need to bring this 9 down. It doesn't magically disappear, okay? In math, things are not magic. Things can't just disappear all of a sudden. You have to manipulate things in order to get rid of it. Okay, now notice here, 4. Is that a perfect square? Yes. What about 1? That is also a perfect square. So if you're like, 1 wasn't, yes it is. So this is a difference of squares because our a value and our constant are both perfect squares. We have a binomial. It is subtracting, and we don't have that middle term. Okay, what's the square root of 4? It's going to be 2. And what's the square root of 1? That is 1. Remember, you can just plug that into your calculator if you need to. If you do not know if a number is a perfect square, just plug it into your calculator. Take the square root of it. If it gives you a nice number back, then it is a perfect square. If not, meaning you get a decimal, then it's not a perfect square. Okay, so 9 times 2x minus 1 times 2x plus 1 is our answer there. Okay, we're going to have a few more problems, so make sure you watch part 3 of the 4.4 note.